Hi, students. In this lecture, I am going to discuss problems based on LC oscillations. Let us see first one. See the question given. Figure shows an LC circuit where capacitance 1 farad, inductance 4 Henry. At time t equal to 0, charge in the capacitor is a 4 coulomb and it is decreasing at a rate of root 5 coulomb per second. Maximum charge of the capacitor is. Okay. Let us see how to start. So charge maximum. So first of all, we have to focus. Let me draw a diagram, that given diagram. So given diagram, given it is capacitor, which is connected to an inductor. Inductor given inductance value 4 Henry, capacitance given 1 farad, and taking this as a plus, this is minus, and suppose charge is Q at 1 instant. Okay. Right. So first of all, we have to focus charge value given 4 coulomb at t equal to 0. Now he's asking maximum charge. Let us take it as a Q naught maximum charge, which we have to calculate. So now we have to see in LC oscillations, there is no loss of energy. Energy transfers, or you can say oscillates from capacitor to inductor and inductor to capacitor. Okay. Energy is simply transferring from capacitor to inductor. Then from inductor to capacitor, there is no energy loss. So what I'm writing here, when it is having maximum charge, energy will be completely in the form of electric potential energy, means only in the capacitor. Okay. So what I can do here, energy conservation Q naught square by 2C. C value 1, that is equal to now present value Q square, that is a 4 square, upon 2C plus half Li square, L value 4, I value dq by dt, condition given at what rate charge is decreasing. So dq by dt, dq by dt value minus root 5. So why minus means? Because it is decreasing. Okay. So current equal to minus dq by dt, that is root 5. So half Li square. Okay. Now see calculation. So first cancel both sides 2. Then remaining one is now Q naught square is equal to 16 plus 4 5 20. That means a Q naught value, it is a 6 coulomb. That is now maximum charge. That is now maximum charge. And see next what we have to calculate. Next we have to calculate charge of the capacitor will be maximum at time t equal to, is asking charge of the capacitor becomes maximum, right? At what time? Now see what I can do here. So first I'm writing here charge Q equal to Q naught into cos omega t plus phi. Okay. See why I have chosen cos function instead of sine function. Okay. Right. Coming to here, maximum value 6 we got. When t equal to 0, it is how much? 4. So 4 equal to 6 cos phi. Okay. That means cos phi value 2 by 3. That means a phi value less than 90. Okay. So now here, t value 0, 5 value less than 90. As time passes, at one point of time, this value becomes 90. So up to that instant, cost value will decrease. That means charge is decreasing. This is matching with the given condition, right? Given charge is decreasing. Suppose I am taking a sine function. Then see what happens. T0, sine phi equal 2 by 3. Now as time passes, this value, sum becomes at one point of time 90. Since this value increasing, charge has to increase. Okay. That's why I have taken here cost function. Okay. Right. So condition is that now this value less than 90. Right. When this value becomes 180, then modulus of this value becomes maximum. What I am saying, modulus. See carefully once. Suppose this is a charge on the left plate. Okay. Then charge on left plate is 0. Sorry, charge on left plate is maximum when this function is 0, or when this function becomes a 2 pi. I am saying on left plate. Okay. But if you focus modulus of the charge on left plate, then when I'm taking this is 180, then also modulus of the charge on left plate becomes maximum. Okay. Because if this is minus q naught, this becomes a plus q naught. Then what we are saying, capacitor is having maximum charge. Okay. That's why I'm taking here. If omega t plus phi becomes pi, charge is maximum. Okay. So condition is omega t plus phi is equal to pi, right? Then t value, see how much? Omega t equal to pi minus phi. Phi value cos inverse 2 by 3, right? Pi minus. And see, coming to omega value how much? Omega equal to 1 by root LC, right? This is what we have learned in the last lecture. That is 1 by LC. L value 4, C value 1. So 1 by root 4, that is 2. 1 by 2. Okay. This is now omega value. Substitute that here t value. So t equal to 2 into pi minus cos inverse 2 by 3. Okay. Check it once. It is 2 into pi minus cos inverse 2 by 3. Okay. At this time, charge becomes maximum. Okay. Because this total value, how much? It is equal to pi. Right. Okay. Now see the next question in that. Coming to the next question. Choose the correct option from the following. Okay. Maximum current in the circuit is 4 ampere. Right. See how to verify that. Differentiate this one. Okay. I will get dq by dt. dq by dt, that is equal to q naught omega. It is a cos, derivative of cos minus sine. So minus sine omega t plus phi. Okay. This is now current. So here what I can say is, if I'm focusing modulus of q naught omega, that is giving us a maximum value. And what is a q naught? It is a 6, right? So maximum, I'm taking it as I equal to I naught into the cos function. So I naught value Q naught is 6, omega value 1 by 2. That means maximum current, it is 3 ampere. Okay, right. And so the next option, when current is a half its maximum value, charge in the capacitor is less than half its maximum value. When current is a half, then see what we can do. So, to find a charge when current becomes a half, okay, use energy equation once again. So I'm writing once again energy equation. To verify this option, so taking energy equation, so present the charge we want to calculate. So what I can do here is now energy equation. Present it is not correct. And is asking like when current is half its maximum value, charge on the capacitor. Okay. Maximum value 6 we got. So it is Q naught square 36. 36 by 2. Q square by 2. So that is equal to Q square by 2C plus half L I square. Condition is given. So what is given here? Current is a half its maximum value. Half its maximum is 3 by 2. Half L I square. 36 by 2. It is 18. That is equal to Q square by 2 plus 2 here 2 times. And I can say 3 by 2 whole square 4 and this 4. Remaining is now how much? It is 9 by 2. Okay. That means what is the value here? What is the value here? 9 by 2. And I'm taking 2 here. 36. 36 minus 9. 27. 27. So Q value 3 root 3. Okay. And but what is given here is less than half its maximum value. What is the maximum value? 6. Half value how much? 3. Right? But given it is now, is in less than half its maximum value. But this is now more than half its maximum value, right? Half value 3. This is more than 3. That means option B is wrong. Okay, option A also wrong. Therefore, correct option is it is Delhi. Both A and B are wrong. Right? Like this, we can solve. Let us see next problem. Let's see the question given. An inductor and two capacitors are connected in the circuit as shown. Initially, capacitor A has no charge and capacitor B has CV charge. Assume that the circuit has no resistance at all. Means purely LC, right? At t equal to 0, switch SC is closed. Then, and given condition here, and CV value 100 millicoulomb. Okay, right. When current in the circuit is maximum, charge on each capacitor is the same. Let us see how to verify these options. First, make the given diagram. See the circuit given. So first of all, it is an inductor is given. Next, capacitor. And one more capacitor here. Right, this is A and this is B. And given plus minus charge equal to CV. Okay, plus CV minus C. Actually, in this, they have to mention capacitance of B also. Okay, see once the question what is given. And two capacitors are connected in circuit as shown. Initially, capacitor A has no charge and B has CV charge. Assume, okay. Okay, regarding capacitance not mentioned. Okay, let us do one thing here. We are taking the assumption that both are having same capacity, that is a C. Okay, then only we can get options here. Okay, right. Now see what we have to verify. When current in the circuit is maximum, charge on capacitor is the same. First thing, current maximum. Then see what happens. Current maximum means di by dt. will be zero, first thing. Therefore, what I can say, EMF induced across the inductor, that is L into di by dt, is zero, right? So same logic we have taken the last lecture also, right? That means across the inductor there is no EMF induced. Therefore, across this capacitor and across this, both are now having same potential difference, right? See carefully once. There is no EMF induced across this. So this point and this point both having same potential. Next, this is a conducting wire. So these 2 points also having same potential. Means the potential difference is the same. So same potential difference, right? Same capacitance, the same potential difference. That means charge will be same. Okay. I hope you are getting this point. Since there is no EMF induced here, at all these points same potential, at all these points same potential. Therefore, across this potential difference and across this potential difference, both are same. Same potential difference, same capacity, therefore same charge. Okay, that means A is now correct. Okay, current in circuit maximum, charge on each capacitor is the same. Okay, and you see C value given how much? Given 100 millicoulomb. That means this charge divides now equally. So here 50 and here 50. Okay, right. And you can see option B, and that is wrong because A is correct. Coming to C, he's asking charge on B. Charge on B, we have to calculate. Okay, suppose this is a Q. This is now Q dash. Okay, so first thing, charge on these two plates, total charge must be constant, and that value must be equal to, see how much? Q dash plus Q should be equal to, always equal to 100 millicoulomb, because coming to these two plates are not connected to any other circuit. Okay, that's why total charge must be always 100, right? Okay, now we have to get the value of Q. Then see what we can do. Suppose I'm taking current is I like this. So why like this means its a charge is now decreasing. So charge flows like this, positive charge. So current is now clockwise. Okay. So now I'm taking here Kirchhoff's second law to get Q charge. Okay. Let me take from here. I'm taking from here. I'm taking now. The path is now clockwise. Okay. If I'm taking from here, first we have to replace inductor with an equivalent battery. Okay. Now you can see initially no current. Now current starts increasing from zero, reaches a maximum value. Then current starts decrease. So since the current is now increasing, it tries to oppose the cause. So it tries to decrease the current. Therefore, I am replacing this with a battery, and that battery must be like this. Okay, right. Because it has to oppose, it tries to decrease. Okay, so I am moving from high potential to low potential. So writing here minus L into di by dt. And we can see di by dt value positive because current is increasing. Next, coming to here, low potential to high potential. Therefore, plus Q by C. Next, coming to here, this becomes a plus, this becomes minus. So high potential to low potential. Therefore, minus Q1 by C. Or I can write Q1 in the place of Q1 means Q dash. I can write CV. This is CV, right? CV minus Q. Okay. Q by C equal to 0. This is now equation. Now we have to simplify this equation. Let us see how to simplify. In the place of Q, what I can write. So you can see here, this is now dq by dt, right? dq by dt. And you can see here charge is now decreasing. Therefore, Here I have to write minus L into, it is a minus d square q by dt square, because the charge on this plate is now decreasing. That's why I have taken minus, plus q by c, minus of minus plus 2q by c, 2q by c minus cv by c equal to 0. Now make calculation carefully. So minus of minus of plus d square q by dt square plus 2q by LC. I'm taking this outside. 2q by LC. Remains what is left. Or do one thing. Let me take q inside, because that is make our calculation more easy. Let me take q inside. 2 by LC. I have to take q inside here. Q is here. Minus what else left? 2q by LC minus here CC cancelled, right? It is now, that means what is left here? So only C and V. Let me cross check once. 2q by C, 2q by LC. I have an L here. CC cancelled, V by L. CC cancelled, V by L. So equation correct only. Now see how to write this equation. I am writing this equation as d square by dt square of q minus cv. See, we can write like this, nothing wrong with this one. The reason is that cv is a constant. In such a case, if I'm taking double derivative of a constant, it is 0 only, right? So nothing wrong in this. So q minus cv equal to 0. Okay. Now we can see this is of the form. If I'm writing this with some other notation, suppose some value, if I'm doing some other notation, let me write this as d square y by dt square plus, this is now, see what is it? Omega square y equal to 0. What is y here? Y is now q minus cv, right? That means here y is changing now simple harmonically. So I can write here y equal to, y means q minus cv, y equal to some amplitude. Okay, let me take what that amplitude here. So here what amplitude we have to write here? That is the maximum charge, yes or no? I'm taking as some q naught, maximum charge on this one. Okay, in fact that maximum charge is nothing but 100. Okay, so this is now, and see anything else I am missing here. Cross check once. As I am missing here, it must be cv by 2, because 2 is at 2 and 2. So it must be cv by 2 calculation. Okay, so it is now q minus cv by 2. So q minus cv by 2 is equal to q naught into, I'm writing q naught into sine omega t plus 5, right? Okay, so from this q equal to cv by 2 plus q naught. Let me see once. So what is the value of q naught? cv value 100. Okay, cv by 2, it is a 50. This is a 50. What about q naught? I'm writing once again here. Q naught into sine omega t plus 5. Now, when t equal to 0, t equal to 0, here charge was 100. Okay. Therefore, this is now 50. That means this total value must become 50. That means when t is 0, 5 value should become, 5 value should become how much? 90. If this is 90, then this value will be maximum, right? That means from this written condition that phi equal to 90. How much phi value? It is 90. So it is now CV by 2, that is 50 plus 50. T value it is we got 90. Therefore, it is now sine omega t plus 90. This is now chart as a function of time. And see options what they have given. I think option given like cos, right? This is now cos omega t. 50 into 1 plus cos omega t. And what is omega value? Omega value is now, you can see here, omega value. Omega square is 2 by, so omega value root of 2 by LC, right? Omega by. Okay. And you can see here, the value of LC already given. In that, if you take LC value, we are going to get, it is 100 pi. This is the value of omega by taking the value of LC given in the question. It is 100 pi. That means option C is match. Okay. So if you observe carefully, first of all, we have taken here, it is a loop equation. Writing loop equation, then converting into the standard form of SHM, d square y by dt square plus omega square y equal to 0. Right? I hope you got a clarity. Let us go for next question. See the question given. In the circuit shown, the switch S is shifted to position 2 from position 1 at t equal to 0. Having been in position 1 for a long time. Condition is the switch was in position 1 for a long time. The current in the circuit just after shifting off a switch will be. Condition is battery and both inductors are ideal. Okay. Right. Let us see how to start and see what is the key point to start the problem. So first of all, make the given diagram. An inductor of inductance of 5L. Okay. A battery is given. This is a switch. And this is a position 1. So having here one more inductor. This is a 4L. This is now position 2. And this is now resistor connected to battery. Okay. Right. Now see what he is saying. See the question once. This switch was with position means position 1 for long time. Long time is what happens? Current flows like this in this way. Long time means the current becomes steady. That the current value, steady current equal to this is given E. It is equal to E by R. After a long time, current becomes a constant. Then inductor has no role. So it is simply E by R. Okay. Now we are, initially it was Lagis. Now connecting to 2. Once we're connecting to 2, what happens? This is now circuit. Okay. This is now circuit. That means now inductance has changed. But remember, question is that just after switching, just after shifting the switch, just after means flux does not change immediately. So flux remains same. Condition is flux remains the same. That means L into Y remains the same. Because this is, he is asking just after. If you remember, while solving questions based on springs, There we have discussed like just after cutting the spring, its elongation or its compression does not change immediately. Almost same kind of logic. Okay. Therefore, what I can say is initially inductance was 5L because this was circuit initial. Okay. Initial circuit was like this. So 5L current E by R, that was the flux just before shifting the switch. Just after shifting, what happens is now these two are becoming series combination. Inductance becomes 9L. Current we have to calculate. I'm taking a side. Okay. Now L comes. So I equal to 5E by 9R. So this is the current in the circuit just after shifting the switch, just after. That's why no change in the flux. This is the key point which we have to keep in mind. It is just like comparing with spring. Just after cutting, its elongation or compression does not change immediately. Okay, so I hope you got a clarity.